Another quantitative technique, known as precipitation titration, can be used to determine the concentration of chloride ions in a seawater sample. By using an indicator in a precipitation titration, we can determine when the equivalence point has been reached. In the precipitation titration of silver ions with chloride ions, potassium chromate is used as the indicator. When it is added to the water sample containing the chloride ions, it is a pale yellow colour. Silver nitrate is added from the burette to the conical flask containing the chloride ions and the indicator. The conical flask is placed on a white tile so that the colour change can be easily observed. Whilst the reaction between silver ions and chloride ions is taking place, the potassium chromate does not change colour. When the reaction reaches the equivalence point, all of the chloride ions have reacted to form a precipitate of silver chloride. When more silver nitrate is added, the potassium chromate undergoes a colour change, forming an orange-red solution. This is because once all of the chloride ions have reacted with the silver nitrate then reacts with the potassium chromate, which makes it change colour, according to the equation shown, where now silver chromate and potassium nitrate form. By determining the volume of silver nitrate needed to completely react with the chloride ions in the conical flask when the colour change occurs, the concentration of chloride ions in the seawater sample can be determined. To determine the concentration of chloride ions in seawater via precipitation titration, a 10.00 ml aliquot of the seawater sample is placed in a 250 ml conical flask. 1 ml of the indicator, potassium chromate, is added. The burette is rinsed and filled with 0.2001 molar silver nitrate solution. The silver nitrate solution is added to the conical flask containing the chloride ions and the indicator until the colour has changed from yellow to orange. Once the colour change has occurred, the endpoint has been reached. The volume of silver nitrate needed to cause the colour change is used to determine the concentration of chloride ions in the seawater sample. The titration process should be carried out 4 times, once to get a rough idea of where the colour change will occur, and then 3 more times to get more accurate values. If the titration was performed using 10.00 ml aliquots of the seawater sample and it was found that the average titration was 26.32 mL of silver nitrate, then this volume can be used to calculate the concentration of chloride ions in the water sample. The number of moles of silver nitrate used can be determined by using the formula N equals C times V. So, 0.2001 molar times 0.02362 litres equals 4.726 times 10 to the minus 3 moles. So, the number of moles of chloride ions in 10.00 mils is the same. Let's now determine the mass of chloride per litre. Since the 10.00 ml aliquot contains 4.726 times 10 to the minus 3 moles in 1 litre, there will be 100 times this value, which is 0.4726 moles. The mass of chloride ions will be 0.4726 times its molar mass of 35.45 grams per mole, which equals 16.75 grams per litre. Therefore, the concentration of chloride ions in this sample of seawater is 16.75 grams per litre. Gravimetric analysis and precipitation titrations are 2 methods to determine the amount or concentration of ions in samples.